All right, let's put it all together. First of all, in the background, you might hear the dishwasher going, got to multitask, got to get all these things done. So sorry about that. We're going to do compound inequalities, systems of equations, systems of inequalities, and absolute values. And we're going to graph all of these because you're going to have a quiz over graphing test actually pretty soon. So compound inequality, remember, compound inequality is going to be either, so it's two inequalities. I don't remember doing this. Two inequalities solved at the same time, simultaneously. Is that word? I don't really know how to spell it. Compound inequality containing and is only true if both inequalities are true. The intersection can be found by graphing each inequality and then determining where the graphs overlap. So remember, that has to satisfy both. That's where if you've got a green going this way and an orange going this way, where do they both overlap? The union or a compound inequality containing or is only true if, or is true if either of the inequalities are true. The union can be found by graphing each inequality. It doesn't have to satisfy both, it only has to satisfy one or the other. All right, so we're going to graph this compound inequality. Here's our or. I'm going to separate it because they're really, really close together. I'm going to only look at this one on the left. M minus 2 is less than negative 8. I'm going to add 2. M is less than negative 6. Now I'm only going to look at the one on the right. M over 8 is greater than 1. We're going to multiply. Opposite of division is multiplication. So we're going to multiply both sides by m over 8. We're multiplying by a positive, so we don't do any changing. M is greater than 8. On my number line, I want negative 6. I want 8. Some people want you to put 0 in there, so I'll put it there in case your teacher wants that. And means, oh, this is an or. This is an or. Or means we graph on the line. Now, some teachers don't do that, so I'm going to try to do it both ways. Here's m is less than negative 6. Here's m is greater than 8. Anything that gets graphed is on the line. So our answer is where m is less than 6 union with m is greater than 8. Remember, union is the same thing as or. That was kind of a hot mess. All right, so this one is, there's no and or, it's an implied and. It's telling me that 9 plus n is greater than negative 1 and 9 plus n is less than 17. So on this one, I've got three parts. I've got a left, I've got a middle, I've got a right. The left makes the decisions for me. No, it does not. The middle makes the decisions for me. So if I'm looking at 9 plus n, to move that 9, I'm going to subtract 9. I have to do it from the middle, from the left, and from the right. I have to do all three parts. Negative 1 minus 9 is negative 10. You're going to bring down the same sign they gave you. These, the n, 9's cancel out. You have n. Bring down the same sign. And 17 minus 9 is 8. Now on this one, I do not do anything except graph the negative 10 and the 8. Because n is trapped between those two, I just trap it right between. The 8 is not including and the negative 10 is not included. So n is bigger, that's this way, bigger than negative 10, and it is less than 8. So it's the stuff in between. It's a cheater though, you don't even have to worry about it. It's lazy, just graph it right in the middle. All right, graphing systems of equations. Systems of equations are two systems, or two equations that we're solving simultaneously again. All right, has to be at the same time. You're going to get 3 possible solutions, no solution if they're parallel, 1 solution if they cross, and the same line, infinitely many solutions if it's the same line, just with different equations. So to graph this one, I'm going to graph this top one, y equals 2x plus 4. I'm going to start up 1, 2, 3, 4. My slope is up 2, right 1, up 2, right 1, down 2, left 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 1. Equations are the ones where you have to be extremely accurate. You have to graph them both, one of them all the way through and the other one until it hits the first line. 1/2 x plus 1, y-intercept of 1, slope of up 1, right 2. That's taking me away from the line, so instead of up and right, I'm going to go down and left. Whoop, bingo zingo, there it is. Now, because I'm a lousy artiste, I'm going to graph all the way through so I can get that line. My solution is the point where they cross, and that is the point -2, 0. Okay, this one, this y equals -3x. I don't like that. There's a plus 0 implied. You start at the origin. Your slope is down 3, right 1. So we're going to go down 3, right 1, and then we're going to go up 3, left 1. And we're going to try really hard to draw a nice straight line connecting all the dots. Look at that. All right, this one, x plus 4, my y-intercept, I begin on the y-axis at 4. My slope is up 1, right 1, up 1, right 1. Again, I'm going away from the line, so instead I'm going to go down 1, left 1. I ran into the line. Oh, come on. Oh, that didn't work very well. Okay, I'm drawing this line. Oh, there it is. Look at that. Showed up. My solution is the point where they cross. That is left 1, up 3, the point -1, 3. In inequalities, you have to make sure that they are both in slope-intercept form. That's true for equations too. Slope-intercept, y equals mx plus b. Graph all inequalities individually, shading as you go. And the solution region, or the solution set, is where the shaded areas cross. All right, so we do this the exact same way. We start at 0, -1. Start on the y-intercept. Slope is up 2, right 3, up 2, right 3, up 2, right 3, down 2, left 3, down 2, left 3, down 2, left 3. Now, on this particular one, it's got an or equal to, so it's going to be a solid line. It also has y is less than, so it's going to be below. So I'm going to draw a solid line. Oh, I'm so bad at that. Where did it go? My solid line disappeared, guys. Did you see that? It was there and then it was gone. There it is. Down below is down here. Okay? Now on this one, I'm going to begin at 0, 5, up 0, 5 on the y-axis. That negative goes with the numerator, so it's down 4, right 3. 1, 2, 3, 4, 1, 2, 3. Oh, it's the same point. Don't care. 1, 2, 3, 4, 1, 2, 3. I would care if it was equations, but on inequalities, I only care the colored in region, the shaded region where they cross. So on this one, I've got y is greater than. There is no line, so it's going to be dotted. And I'm going to shade above. So here's my dotted line. Here's above. Where do they cross? In this area over here. Remember, if you were asked for a point in the solution set, any point over here works, any point on the blue line works, but any point on the red line does not. All right, so once again, we're going to do another inequality. We're going to start with it at 0, 5. My slope is up 1, right 2. Just going to do a whole bunch of those little up 1, right 2s and down 1, left 2s. And then I'm going to look, it says this. That is a dotted line. It is not solid. And it is above. Then I'm going to go to this one right there. 0, -2 is where I begin. Don't know what that blue globble is there, so we're going to get rid of it. My slope is down 3, right 1. Down 3, right 1, or up 3, left 1. I want to go through the whole grid because I'm not a very good artiste. This is y is greater than. There's no equal to line, so it is also dotted. and greater than is above. Where do they intersect? This region all in here. None of the points on either the blue line or the red line will be solutions because they are both dotted. Okay, absolute value. We got to find the vertex. We got to choose two x values. We got to plug in values. We're going to plot the points, draw the lines. It's going to be very exciting. Makes a V, remember? Makes a V, value. So this is just absolute value of x. So to find the x of the vertex, we take the stuff inside the absolute value marks and we set it equal to 0. So our middle point, I'm going to put 3 points on here. Our middle point is 0. To find the y that goes with that, remember this is a big Y. So y is equal to the absolute value of 0, which is just 0. There's 0, 0. Then I'm going to go 2 to the left. So I'm going to go to -2. If I go absolute value of -2, that is 2. So -2, 2. Then I'm going to go 2 to the right. 0 plus 2 is 2. Absolute value of 2 is 2. So write 2 over 2. And I get my beautiful absolute value V. Okay? Now, I say go left 2, right 2. I don't know what your teacher told you, so you might have to do it a little differently. But left 2, right 2 is a good thing to do. All right, so on this one, I've got x plus 3 inside the absolute value bars. I set it equal to 0, and I solve for x. That gives me my middle x value. Okay, to find the y, remember this is a fancy way of saying y. It's the absolute value of -3 plus 3. That's the absolute value of 0, which is 0. That's my vertex. I'm going to go down 2. So -3 minus 2 gives me -5. So I'm going to put -5 in for x. That gives me the absolute value of -2, which is 2. So I'm going to go left 5, up 2. I'm going to add 2, and that takes me to -1. I'm going to put -1 in for x. -1 plus 3 is 2. Absolute value of 2 is 2. So I'm going to go -1, 2, and I'm going to get, oh, that's really so close. I didn't hit either one of the points, did I? Oh, that's awful, you guys. Guys, that's bad. All right, there we go. That's a little better. All right, with Christmas coming, doesn't this kind of look like a reindeer? There's its little antlers, put some ears on there. Yeah, okay. Oh, gosh, that was my last slide, and that's a reindeer. That'll be our secret word, reindeer.